Awesome. All right. Thank you again for being with us. And Polly and Crush, thank you for being with us. We'll let you take it away.
Awesome. Thanks, Mary Lee. And hello. Polly Crocker here. I'm with DES in the Watershed Management Bureau's coastal program. I administer two of the ARPA funded grants that come out of the coastal program. And one of those is the Culvert Flood Risk Assistant Grant. So I've been thinking a lot about replacing and rehabbing culverts for the past year in this position. Unfortunately, there's no more pandemic era ARPA funding, so I'm actively seeking to get more dollars to kind of keep these types of projects going. And one of my grant projects is a partnership with UNH. That's what we're going to talk about here today. So my background is stormwater. I was saying my first job out of undergrad was replacing culverts in northern Vermont, super rural watershed with farmers and camp owners, replacing culverts there in the name of water quality, and then ended up working for VTrans as a consultant doing culvert assessments, and I can't seem to get away from them. So excited to be sharing with you guys.
Yeah. So my name is Kurosh. I'm a second-year PhD student at the University of New Hampshire, and my advisor is Dr. Wei Mo. My major is civil and environmental engineering, but my research area, me and my advisor, is looking at the bigger picture and find win-win solutions. So the gist is system level prioritization and management. And here for this project, we are focusing on stream crossings. But before that, we had Dr. Bebe Mo had projects with dams and solar energy and any other system level management. So with that, we can start the presentation.
All right. Yeah, and our presentation is about 20 minutes, just so you know, and then we'll leave time for Q&A at the end. We'll go over our project team. I'm going to do an overview of, what New Hampshire's been focusing on with stream crossings to date. Crush is going to get into the project details, and we'll talk a bit more about our engagement survey, which is the ask at the end of this presentation. So on my side of the house at DES, I also have Kevin Lucy supporting this project. He's a habitat coordinator at DES, but he's been working on culverts for quite some time as well, more from the kind of restoration and aquatic organism passage aspect. He developed our tidal culvert stream crossing assessment protocol, and they did a prioritization project, a part of that work in 2019 and 2020. And so he's been at DES for, over 15 years and brings a lot of experience to the table. And then, as Karash said, he's working under Dr. Wei Mo at the College of Engineering. So we've got our team making it happen, leading the way. We also have a very robust technical advisory committee. I think we're up to 24 people now. And it's a mix of the state agencies that are working on stream crossing, so DES, DOT, Fish and Game, as well as a few of the regional planning commissions. They're kind of our arm to the municipal level, as well as T2 here. So we're finally getting to talk to you guys. We were also invited the Nature Conservancy along. They do a lot of implementation in the name of climate resiliency restoration, and bring that nonprofit kind of partner lens to the work. And then as well as Streamworks LLC, they're a private consulting firm that does design and implementation work. So trying to get a good representation from the cross-sector nature of this work. And they've been helping drive a lot of our focus. So why are we talking about stream crossings? I have a feeling you folks might know on kind of the front lines in the municipal transportation world, but a lot of crossings are old and undersized, and the weather patterns as of late have really been highlighting that fact. So a big angle for me with stream crossings is public safety and flood resiliency. So trying to make these things work for us for the next 50 years as many of our assets get old. There's also a lot of environmental benefits or impacts from stream crossing. So here we have a bunch of sad alewives that can't make it through this perched culvert. There's also with perched culverts and undersized culverts can come a lot of erosion, which impacts water quality. So there's a lot of reasons to be thinking about culverts and small bridges, and we have 20,000 of them in New Hampshire. So it's no small feat. There's a continual line of culverts ready to be worked on that need attention. So We're also partnering with the New Hampshire Stream Crossing Initiative. I just wanted to throw this in here for context. This group was formed in 2006, 2007 as a result of the Patriots Day and Mother's Day storms back then, where there was major catastrophic funding, if either of you were around. The need then was, hey, which culverts are undersized? Which culverts are in bad shape that might go if there's a big storm event? Which ones are preventing fish passage? So they developed this, first, I'd say 10 years of that group was developing this field manual to do a standardized assessment of each stream crossing. And a lot of the regional planning commissions have been hiring summer field crews to make that happen. Each of the state entities involved with the Stream Crossing Initiative have been hiring summer interns to get out there and measure these crossings. It's no small thing. Each crossing under this protocol, there's 90 data points that are collected, and it takes upwards of 45 minutes per crossing. So it's no small ask to do this data collection, but the bonus is you get these standardized scores. So geomorphic compatibility, does the stream fit the crossing that it's passing through? Aquatic organism passage, can the critters get through? Asset condition, that's a quick glance at, how is the culvert or small bridge itself doing? And the main one that I think is a big incentive to collect this data is flood vulnerability. So if you collect all this data, it gets put into DES's database, and we actually run a model for each individual crossing that says, can this crossing pass the 2-year, 5-year, 10-year, 50-year, 100-year storm? So you get that data if you go through this data collection process. And since 2006, 70% of the stream crossings in New Hampshire have been assessed, which is an incredible feat. So we have this amazing data set. It's on display, of course, online. So it's the SAIDS, it's part of the SAIDS data, which is run by out of UNH Extension. T2 kind of handles a lot of that. So if you're familiar with the closed drainage system or the road management surface data sets, the stream crossing data set is a part of that suite. It's displayed in the aquatic. This is the aquatic restoration mapper here on the screen. So I just want to make sure everyone knows it's out there. The data's been collected over the decades. You can see it here, and this map tells you a lot of information. Like this purple line tells us that brook trout live on this stream where this culvert is. Each culvert has a lot going on. You can see all these different colors. It's telling you, can it pass the 10-year storm? In this case, no, it can't. It's red. Is it in good condition? No, it is not. Can it pass aquatic organisms? No, it cannot. Does it fit the stream that runs through it? It looks like it can. So each of these data points has quite a bit of information packed in. We also at DES hire someone to digitize each town's hazard mitigation plan as it gets published, as they get published every five or so years. So these black flag data points right here indicate that an issue or a project has been identified in a hazard mitigation plan. So the idea here is that with this type of information, you can see a lot of what's going on at each of these sites, culvert by culvert. I see each of these data layers as like a feather in your cap for a grant application. It's another reason why this culvert should be replaced rather than just the fact that it's been flooding out every year and I've been dumping asphalt on top of it because it's falling apart. So that's what our project is really about, is trying to make this what is now a great data set, but you really have to know where to go to find it. You have to know where to click on how to turn all these layers on. And then the next step is knowing how to use this data for funding. So then you have to go onto the SCI Stream Crossing Initiative website. There is a table that we have that has like check boxes for these different funding sources here. So for example, the HSCM hazard mitigation grant, you are eligible for that grant if your culvert increases the capacity of a flood hazard, eliminates a hazard, etc. So you can see how each of those data layers can get you eligibility for a grant. But again, it's a very manual process. So a lot of our project is kind of trying to streamline and synthesize a lot of this data for folks. And we're also trying to get folks to plan ahead. I mean, there's always going to be an emergency. You always have to fix those culverts that are failing. This is an example here of one of my grantees. They tried to plan ahead. They got the ARPA grant, the culvert replacement grant that I run. But just 2 weeks ago, at the end of April, this box culvert, 70 years old, went ahead and collapsed. So they had to do an emergency repair. And they're going to have to now go in and do the big repair that we've been designing for the past year, which is a 16-foot precast box culvert. So, trying to reduce having to fix things twice, trying to give folks the ability to plan proactively while also responding to emergencies, and bringing a lot of stakeholders together to bring more resources to these projects and the people that are working on them. So it's not just the road agent trying to make this happen year after year through your town budget. This is just to show, a lot of people have been thinking about stream crossing replacement in New Hampshire for a long time. Kind of the first half of this timeline is all about collecting that data, developing standardized protocols, and more recently, kind of watershed by watershed, folks are starting to think about stream crossing replacement and prioritizing multiple stream crossing replacements at once by watershed. So most recently, the Warner River did this. They partnered with their nonprofit group and Plymouth University, I believe, and Fish and Game to do a prioritization project and think about which culverts in the scope of a watershed need to be replaced first. But these studies have been super amazing and helpful in using that data, but they're kind of a little bit one-off. You got to hire someone to make it happen for you. They like the Warner River watershed one is very focused on fish passage, so all the results are fish passage oriented, but that might not be your town or your watershed's priority. So we're trying to come up with some flexible ways to make prioritization of culverts happen. So that's the goal of our project here. We're working on developing a prioritization framework for stream crossing replacements that achieve more than one goal, not just fish passage, not just, replacing old defunct culverts, not just the ones that flood, but the ones that can check a lot of those boxes. Because this example photo here, this is what was a 9-foot culvert in Barrington. It was significantly undersized and it was not allowing fish to pass through. It was replaced with a 50-foot bridge. So it took 13 years to complete this project, multiple grants from multiple agencies over multiple grant rounds. And so these projects, they have to do more than just one thing. So that's what we're really focusing on here, is finding the win-win scenarios that make these projects happen, hopefully at a little bit of a faster clip than what we're currently working with. So
yeah,
with that, I'm handing it off to Karash.
Thank you, Polly. So yeah, as Polly mentioned, it's a multifaceted prioritization and it touches many places. So with this, I'm going to start to give a brief introduction about this project and then talk more about the methodology. So this project was funded under American Rescue Plan Act, and the goals here, the first one was to create comprehensive stream crossing assessment data set for 2 pilots, Salmon Falls, Piscataqua, and Merrimack River watershed. Next, which is this stage, we are trying to understand and characterize stakeholder interests and priorities related to stream crossing, which we are trying to do with the survey that we are going to talk about. And finally, having these 2 pieces, we are trying to develop a pilot prioritization model for these 2 watershed so that we can identify opportunities for win-win management scenarios. So to give you updates for the current status of this project, for the field assessment, we could successfully finish all the field assessments during the summer of 2022 and 2023 for that 2 pilot watershed. For the prioritization model, we have initiated the development, and as we are developing a model, we are facing data gaps and we are developing those. So just as a quick example, here you see the word watershed AOP. So traditionally, aquatic organism passage, they look at one crossing at a time. But when we look at bigger picture, if you replace a crossing and it's adjacent to a dam or adjacent to a failing crossing, you're not helping fish passage. So we develop watershed AOP, which is the cumulative probability of passage of all upstream and downstream crossings and the crossing itself. And also for the stakeholder engagement, we, as Polly mentioned, we assembled the TAC, and we have created a list of overarching goals and evaluation criteria and the stakeholders that we are going to talk about later. And the survey has been launched. So with that, I'm going to start with the methodology. So the most used and conventional method for stream crossing prioritization is scoring and ranking. It's pretty simple. The first stage, you select a set of evaluation criteria. Then for each criterion, you would find a score for stream crossings. Then considering all those criteria, you sum them up and you find a score. Then based on that score, you find a rank. So to explain it further with a small example, here on this table, you see a list of crossings. And the four evaluation criteria here, just hypothetically, we brought the SAID score, which Polly mentioned, and imagine that we have scores from 0 to 10, 10 being the most critical. If with equal weight, we sum them up, we can find environmental score. And then the higher our score, the better and the more critical for us. So it would be the first rank. Keeping this in mind, I'll explain our methodology, the concept behind it, and then compare these. So we are proposing to use multi-objective optimization. The main reason is that, as Polly mentioned, it's not just one aspect. There are different aspects. To explain multi-objective optimization with a small example, imagine you want to buy a car. You want it to be as cheap as possible with the horizontal axis being cost and as fast as possible with the vertical axis being speed. So what we are looking for are those dots on the line. If you only care on one side, so you want a fast car, this red car is your car. If you want it to be as cheap as possible, this golf car is your car. But what we are looking are those dots on the line. So we call them Pareto optimal or optimal solutions that we have a trade-off between. When I say optimal, it means for each car model that is not on the line, I can find a car model that has better speed and lower cost. But between these car models on the line, we have a trade-off. If you want a faster car, you need to pay more. So keeping this line in mind, that this is the Pareto. Why? Because it's compared to these, we give us better benefits. I'm going to start to compare these two methods and say how we can benefit. So here we have four crossings on the map that you can see here. If we do two sets of scoring and ranking, the top table is environmental score and the bottom is transportation score. Again, here for all the criteria, we assume we have scores from 0 to 10, 10 being the most critical. For the environmental score, if we assume that we have these four criteria here, the one that Polly mentioned, and with equal weight, we sum them up, we can see that the highest score is for stream crossing number 2. So we give rank 1 to stream crossing number 2 for the environmental score. So if they have funding for one crossing for environmental score, they have to choose crossing number 2. Similarly, if we do a transportation score scoring and ranking, so four typical criteria for transportation are structural condition, annual average daily traffic, road tier, and material, being from 0 to 10, 10 the most critical, with equal weight. If we assume they have equal weight and sum them up, we can see that the highest one is stream crossing number 1. So again, if there is one funding opportunity for transportation aspect, stream crossing number 1 is chosen here. But what we are proposing to do, so with the concept of multi-objective optimization, by looking at different replacement scenarios. So what do I mean by scenarios? These are different combinations that we can choose from these four. We can choose none of them, one of them, up to choosing all of them. So for the sake of comparison, I plotted up to choosing two of them because, as I mentioned, we have two different funding opportunities. So as I mentioned, with the scoring and ranking for environmental score, stream crossing number 2 encircled in a black circle is chosen. Similarly, number 1 with an orange circle around it is chosen with the highest transportation score. Meanwhile, if you look at the bigger picture, with the combined funding, we can find the win-win scenario of choosing 3 and 4, and we can see both transportation and environmental score are higher, so we can gain more benefit with the same funding. But the idea here is just to say we can benefit from replacement scenarios. This was a small example of 4 crossings, 2 funding, but in the real world, we have a single watershed has thousands of crossings, leading to nearly infinite possible scenarios. So it's not simple to list them up. And we have more than just environmental score and transportation score. So we are proposing to do this to maximize multiple stakeholder benefits and minimize replacement costs at the same time. And it enables us to do watershed scale prioritization to find win-win management scenarios. As I said, we have more than transportation and environmental score. We identified 8 overarching goals, trying to be as comprehensive as possible, covering everyone's benefits with the help of our technical advisory committee. As Paul mentioned, we have an inclusive list of technical advisory committee, and we try to cover every ground from environmental, transportation, economic, and societal benefits. So these are the overarching goals that we have. But when we want to optimize these, whether it's maximize or let economic impact minimize, we need to quantify them. So in order to quantify these, for each of these goals, we identified evaluation criteria. Evaluation criteria are kind of specific, measurable, and observable characteristics of each goal. So as an example, for environmental quality, we identified these overarching goals that you can see here, and also we have description for each of these. All of these, again, we co-developed with our technical advisory committee. And so when we have these, we can later maximize all those goals. So here, as just a quick practice, so you see all these 8 goals, and we want you to choose the top 3 goals that you can see. I think you should have a poll so that you can choose the top 3. And then if you want to further discuss it, we can stop sharing and discuss why do you think those are the top 3 for your organization, actually.
I think we'll have to get out of this so we can see the results. Unfortunately. Hold on. Let's see. I think Marilyn was.
Karush, if this is a point where you'd like us to launch that poll, we can do that.
Yeah.
Yeah. Thanks.
Okay.
I'm gonna stop sharing and just reshare the
So we'll ask Sandy and VJ if they're willing and interested to lean in. You're looking for the top 3 goals of the list we have here when replacing a culvert, correct, Coach?
Yeah.
Okay. Yeah.
And since we have 2 participants, if you want to open,
I know, I'm like, you could just give us a shout, but that's all right. We did the poll, so we're gonna do it. Okay, forgot.
So wait for responses. Do we want to choose our top 3?
I hope you closed it. Heyo.
Okay.
Ooh, cool. This is nice.
Yeah.
Thanks, Marilyn.
Flood vulnerability and structural risk, we've got agreement on, and the other 2 are split.
Cool. Actually, that's kind of the same.
I think flood vulnerability has been ubiquitously at the top across all the different groups we've talked to. So that's good to see. And
with that being said, we are going to share screen again. And if you see any goal missing, so you can put that on chat, or even since we have few participants, if you want to shout it out, you can say whether we are missing, because this is part of the engagement. As Polly is going to explain, even for our survey, you are going to give rank for all these goals, and also you can tell us what we are missing, similar to the evaluation criteria, but also you can do that for the goals. If we miss something, you can tell us. If not, well, you can go with the stakeholder engagement. Yeah. I think I'll just cruise and we can save it. We got time at the end too. But yeah, part of what we're asking with our survey is we're asking for direct feedback on these 8 goals and all the criteria that make up each of the goals. So that's the purpose of the survey.
And we can chat about them at the end. If you see anything that's not included here or beyond, we can bring it up. So where we're at now, like I said, we went through, we've been identifying our stakeholders. With the TAC, we got through the overarching goals and the criteria, the measurable pieces of data that will add up to each goal. We're doing these outreach sessions because we launched our survey on March 25th. And then we're going to come back around and report out the survey results as well. And throughout this whole thing, we're getting feedback from our TAC with regular meetings. So here's the survey. The way it's set up, it's being run through UNH. They have a really robust survey, system. Each page of the survey, there's a page for each of the goals. So this, for example, is road criticality. And what we're asking folks to do is weight the different criteria in here. So for example, road criticality has average annual daily traffic, road tier, and detour length are just a few. I think there's 8 total criteria for this goal. And we want you to tell us, is on the spectrum of, is it not important at all to think about average daily traffic, or is it extremely important when you're thinking about a stream crossing? And then, or is it not related? Are we silly for thinking it should be in this list? And then if you're not familiar with something, you can always say you're not familiar. At the end of each of these pages, we ask, are we missing any criteria, or is there something we didn't think of or that we didn't say quite right? You have an option to give input at every single goal. You also have an ability to rank each goal itself. And so that's this kind of giant survey effort that we have going on. And I say giant because it is no joke. It's like a 25-minute survey to get through it. So we're kind of asking a lot of folks. But it's open for a month to give folks plenty of time to make it happen. We've emailed it out to, from environmental to transportation to public safety practitioners in the private, public, and nonprofit sectors across New Hampshire. We had a whole slew of private engineering firms that we've sent it out to. All the regional planning commissions are kind of trickling it down. And we're relying on folks like you to kind of forward it to a friend. If you know of someone who might be interested in providing input to this survey, send it along. And Mary Lee has sent it out to the T2 list, and I think it's also going to do pw.net. And yeah, the deal here is that those weights are actually going to be put into the model. So we're using the stakeholder feedback through this survey result to drive the outcomes of the modeling exercises. That's weighing all these different benefits and also reducing things like cost. That is going to be driven by the survey results. So of high importance because it really is going to shape how this outcome moves forward. And while that's happening, we're working on identifying data for each of those criteria. We're going to transparently share, how we're calculating these things, where are the data gaps, and we're going to start chasing those data gaps based on what people think are important. We don't want to spend the time if it's not going to help you in your job. And then at the end of the survey, we also have what I'm calling like the phase 2 questions, because this is just one project. Maybe you don't need a model to tell you what culverts to replace first. You have a pretty good idea. But the outputs of these models can show you different aspects of your culvert or bridge that might open it up to more types of funding and the types of partners that work on that funding. So we're asking questions like, who else do you work with? What other organizations or technical experts do you work with on stream crossings? Besides funding, which we know is a limiting factor, what are the biggest challenges you see in this type of work? And what other tools, data, or resources could help facilitate stream crossing prioritization in your town, in your county, in your region, depending on your role. So yeah, I mean, I'm on the Upper Valley Regional Planning Commission for my town of Wilmette. We're a small town of 1,400. And I just know that, even working with the RPCs, it's like the bigger cities tend to get a lot of resources because they have the staff to ask for help and to apply for those grants. And, I presented this to them, and one guy was like, yeah, a model's great. That's real nice. And having all this data will be helpful for the people that apply for grants for me. But he was like, I want to size my culverts when I replace them to be bigger so that they can handle the bigger storms I'm seeing all the time now. That would be a better tool. And I was like, oh, okay, good to know. Like, that's something I can look into. So that's also kind of the type of feedback we're looking for, is what are the things that will help you besides beautiful data sets and models that reflect stakeholder interest. So yeah, that's our spiel. I think we'll leave it there. If you guys have any questions about funding this project, anything at all, feel free to chime in. I'm gonna stop sharing. And we'll call it good.
I did drop into the chat pod here the survey link, and then also a link to the mapper tool as well.
Super. Thanks, Lee.
Of course.
Yeah. And thanks for bearing with the recording. We just want to make sure everyone knows kind of what we're up to. So we're trying all the avenues to get the word out. Because this is, I feel like I said, this is the first pulse of funding we've gotten for this type of work. And I'm actively applying for grants to create more tools and do more to support communities to make stream crossing replacement happen in the most efficient and effective way. So